I guess I'm going to start over. I was working on this and it just disappeared. So question 25. They give you the amount of work, 4.8 times 10 to the minus 17 joules. They want it's required to move an electron. They're telling you that Q is 1.6 times 10 to the minus 19 coulombs. And they say, what is the electric potential difference? They want to know what V is. V is equal to W over Q. You have both of those variables. You do the math and you get 3 times 10 to the second volts, which a volt is a joule per coulomb. That divided by that. So the answer is D. Pretty easy if you just read it and pull out what the information is. Next question says there's a proton at point A near a positively charged sphere. That's out here. And if that much 6.4 10 to the minus 19 joules of work, that's W, is required to move it from A to B, what is the potential difference between A and B? Again, we're going to use this same V equals W over Q equation. They tell you the work. It's a proton, same charge as that electron. So basically, question 26 is the same as question 25. Just different words. Just be careful of the words. You do the math. 6.4 divided by 1.6, I believe, is 4. And they both have 10 to the minus 19. So it's just 4 volts. So the answer is B. All right, 27. You have 4 small metal spheres, R, S, T, and U, on insulating stands. Act on each other by means of electrostatic forces. Remember, force K, Q1, Q2 over R squared. It was known that sphere S is negatively charged. The following observations were made. Some of you guys are going to struggle with this just because it's a long question to read and you're going to grow bored with it. Try your best. Sphere S attracts all the other spheres. So if S is negative and it attracts all the other spheres, what do we know about T, R, RT, and U? They are either positive or they could be neutral. That's supposed to be a naught symbol. So we don't know what they are unless there's repulsion. If there's attraction, it could be either positive or neutral. Sphere T and U repel each other. The only way T and U can repel each other is if they're both positive, right? Because they're attracted to S, which is negative, so you know they're either positive or neutral. But if they're neutral, they don't do anything to each other. So we know T and U are positive. And then it says sphere R attracts all other spheres. If R was positive, it would repel T and U. The fact that it doesn't means it's neutral. All right, that answers that question. 28 and 29 refer to the following. A lightweight sphere hangs by an insulating thread. A student wishes to determine if the sphere is neutral or electrostatically charged. She has a negatively charged rubber rod. So you have a sphere hanging from an insulating thread. She wants to know if it's neutral or plus or minus. She has a negatively charged rubber rod and a positively charged glass rod. So this one's rubber, this one's glass. She does not touch the sphere with the rods, but runs tests by bringing them near the sphere one at a time. So she brings this one near and this one's near. Describe the test result that would prove that the sphere in the given situation is neutral. Well, if it's neutral, all right, and we bring this one near it, what would happen? It would be attracted. If it was neutral and I brought this one near it, it would also be attracted. So the test would be if it's attracted to both rubber and glass. Describe the test result that would prove that the sphere in the given situation is positively charged. Well, to prove that it's positive, I can't just bring this negative rod nearby, because if it's neutral, it'll be attracted, or if it's positive, it's attracted. What you'd have to do is bring a positively charged, which is the glass one, nearby, and if it's repelled, then you know that it's positively charged sphere. So in this case, you're looking for repelled by the glass, or the positive one. All right, what is the magnitude of the charge in coulombs of a lithium nucleus containing 3 protons and 4 neutrons? 3 protons, 4 neutrons. What do the neutrons contribute to this? Nothing. So you basically have 3 charges, 3 elementary charges. So it's 3 times that 1.6 times 10 to the minus 19 number, or 4.8 times 10 to the minus 19 coulombs. And the last question, a proton starts from rest and gains that much kinetic energy as it accelerates between A and B in an electric field. Based on the given situation, calculate the potential difference. We want to know V. Our formula for it is W over Q. In this case, the electric field is causing it to accelerate. That work that's being done is turning it into kinetic energy per charge. And we know the charge because it's a proton. So the energy is the 8.35 number. You guys should show your work better than me. I'm running out of room here. And the charge is the 1.6 number. These are times 10 to those. Do the math, and I got 5.22 times 10 to the 5th volts.